Hello students, welcome back to Chemical Kinetics. In this module of the chapter, we are going to understand some more factors which are going to affect rate of reaction. Till now, we have seen the various factors which affect the rate of reaction are concentration for solutions, pressure for gases. We have also seen how temperature affects the rate of reaction. Now we are going to understand nature of reactants. How do nature of reactants affect rate of reaction? Then we will see light, the presence of light, how does it affect the rate of photochemical reactions? And in the end, we will see what does catalyst do to affect the rate of reaction. First, let's get started with the nature of reactant. Let's see how it affects the rate of reaction. Now, before we start with this topic, nature of reactants affecting rate of reaction, I want to ask you, suppose if I have a glass of water. Now, this is the glass of water right here. In this glass of water, I wish to dissolve some sugar. But when I wish to dissolve this sugar, I have two types of sugar. First and foremost, I've got the normal crystalline sugar from the kitchen. I also have some powdered sugar with me. My question to you is, if I want to dissolve sugar in this water, which of them will dissolve quickly? Obviously, the answer is the powdered sugar will dissolve quickly in water. Now this goes on to prove that number one, the reaction is faster if the particles are really small. Smaller particles give a larger surface area for the reaction because the molecules which are inside the particle are also now exposed outside. So the surface area increases. Also, you need to understand that liquids and gases tend to react faster than solids. The reason is simple. It's because liquids and gases have atoms, molecules and ions which are mobile. In solids, they are stationary right there in one place. But that is not the case with liquids and gases. So that's how nature of reactant will affect rate of reaction. Next, we need to understand how light affects rate of reaction. Sometimes you might have wondered, why is it that some chemicals like HNO3, nitric acid, are stored in dark bottles like these in the laboratory? Of course, you might have wondered about this. Now, the answer is very simple. If you take HNO3 in particular, HNO3 decomposes into NO2, H2O and oxygen when it is exposed to light. So basically, if HNO3 is exposed to light, it will decompose. This indicates that there are certain reactions which are photochemical. They take place in the presence of light. So as I told you, this indicates, the example of HNO3 indicates that some reactions take place upon exposure to visible radiation. These reactions are called as photochemical reactions. There's one more thing you need to note here, that such photochemical reactions, they become more vigorous if they are exposed to more intensity of light. Suppose I take this HNO3, early in the morning I expose it to light, and I do the same thing in the afternoon. In afternoon you will see the decomposition is more vigorous. So I can say that the rate of such reactions depends on intensity of the radiation. If the light is very intense, the reaction will be very fast. This is what I mean by effect of light on photochemical reactions. That's all for this module. In the next module, we will see how catalysts alter the rate of reaction. Till then, thank you.